Okay, and then I'm going to look at 22. And 22, you have to do a little thinking on it. Kind of hurts your head. So let's see. Alright, so let me get my calculator and make sure I don't have any mistakes. Alright, so I'd worked mine, but I'd used an angle of, I think, 29, and it should have been 32, something like that. So let's look at 22 and make sure we can get that one done. Yeah, okay. So I used 29 when I first did it, and it should have been 32. Okay, so I have a ball that is kicked, and there's a goalie here, and that angle is, like I said, 32. And it's given an initial velocity of 19 meters per second. And I know from here to there is 29 meters. So first thing I did was get my x and y components. So I said cosine of 32 degrees times 19 meters per second. And when I did cosine of 32 degrees times 19 meters per second, I got 16.11. And then I did sine of 32 times 19 meters per second. And sine of 32 times 19 is 10.07. So I said, well, let's find out how long it rises for. Well, I said VF minus VI over G. So that's a 0 minus 10.07 over negative 9.8. So I found out that it went up for 1.03 seconds. So if it goes up and comes down, back down to the same level, the total time would be 2.06. But I said, well, I don't know. How long does it take for it to move horizontally? So I said the time in the x direction is 29 meters divided by 16.11 meters per second. So it's going to take it 1.80 seconds for the ball to get to the goalie. But it's still on its way down. It's at the goalie, but it's on its way down, because to completely get back to the ground, it would take 2.06 seconds. So the ball is at the goalie, but if I take that 1.80 seconds to get to the goalie minus the 1.03 seconds that it rises, I know that it's fallen for 0.77 seconds. Has to fall. So then what I said was, okay, well, so it's on its way down. I'm going to say that VF equals VI plus AT. As it begins to fall down, that's 0. VI is 9.8. And it's going to fall for 0.77 seconds. So that means it has a velocity of 7.55. When the goalie catches it, that's its vertical velocity. Vx never changes, so that's going to be my 16.11. So when the ball gets to the goalie, it's moving that way with this value of speed. It's falling down with 7.55. So I'm going to do the Pythagorean theorem and solve for V. So V is going to be the square root of 16.11 meters per second squared plus 7.55 meters per second squared. So when I did that, I got V, the magnitude of the velocity, to be 17.8. And then I needed the angle theta with the ground. So that's my theta. So I said tan theta, well, that's also theta, is 7.55 meters per second divided by 16.11 meters per second. These cancel, of course. And so theta was 25 degrees with the ground. The big trick was realizing that it was still falling, because it already had reached the goalie in 1.8 seconds, but it should have fallen for a total, had a total air time of 2.06. So time that it takes to get to the goalie minus the time that it rose for tells me it has to fall for another 0.77 seconds.